code camp. The code camp. Okay, and today we are going to talk about how to remove the teeth, as we mentioned in our first day. Okay, you Mustafa Gamal, you know me already. Start the. Okay, that's good. Okay, so I usually like to start talking about clean code, particularly with people who are juniors or with some fresh experience. Why? Because clean code is something that's like, okay, let's put it in its place first. What? Okay. So I have this. What's happening? Okay. We have three main things. We want to write code, we need to design, and there's something called architecture. So what is the difference between the three things? Okay. Someone control the time, 50 minutes. Okay, for the session. Thank you. So we have these three things: writing code, design, and architecture. Can anyone here tell me how he understands the difference between the three things? Share with me here, his thoughts about that. What is the difference between code and design? Okay.
So writing code is actually implementing the design and architecture. Design.
Writing code is actually implementing.
Yeah.
Right?
Design is about, I think, the UI maybe, and the architecture is talking about how different components of the project is coming together.
Okay, so you are very clear about code and architecture and cappuccino.
Yeah. We can deal with this while we continue.
You forget it?
No, we have it here.
Okay, it's important.
He did it.
Okay, take your time, no problem.
We can continue.
Okay. Thank you. Thank you very much. Okay. So you were clear actually about two main things. The difference between code and architecture. And it's usually clear, the difference between code and architecture. Okay? So can someone provide me a definition for design? He said that code is about implementing, and I like that word very much, because code is about implementing. When I write A = 1, I'm writing code. When I write a function, I'm writing code, right? And when I do this big diagram or define where the components are going to, how the components are going to interact with each other, I'm talking about something related to architecture. So what is design?
I'm not sure, but maybe can we support
Sorry?
object-oriented programming?
Okay, object-oriented programming is part of design. You can design using object-oriented programming or other methodology. Okay, that's why I'm trying to clear the confusion. Actually, it's confusing. Why? Because architecture had a big, you can say, intersection with design. They are share common things, and design share common things with code. Okay, but it's clear that architecture is somehow away from code. But all of them are, how can I say, share some areas. All of them share some areas. It's big area between design and writing code. It's big area between design and architecture, and very tiny area between architecture and writing code. Why? Because the architect should write code. The architect usually writes the skeleton of that project. We had a project at Saudi Arabia before. Okay, it's about emergency management system, ambulance system at Saudi Arabia. We spent 3 months just writing the architecture code. No line of code of the real business. Okay, but it's architecture code related to the real business. It's like we can say proof of concept. We are testing how we are going to monitor the cars, receive the calls, how all the system components will interact with each other. But this exercise that we did actually gave us a great success at the project in Saudi Arabia. That's not usual, by the way. That's not usual. This is You can say
Non-agile.
country
It's
wide.
non-agile.
It's a country because two companies before us failed to deliver that project. So we need to make a good proof of concept, test the streaming, test everything, that everything is interacting. It's actually it's guided by the business, but it's architecture significant requirement part.
I see agile because they just make a proof of concept, like small part, to prove the concept. So I guess it's agile.
But there's no
Agile
delivery.
architecture.
No delivery, just proving and containing.
The delivery here, you can say that the components is talking with each other. You know, we receive the code, we receive the card. Okay, so coding. So coding, it's like, look at this function. Okay, this function, it's for loop, it's coding. We cannot write this function or not. We cannot write this function. It can be. Okay. So we cannot write this function. This is better code for that function. Okay, it's more readable, it's smaller, it's just one line of code. But we can optimize it more. We can make it like that. Okay. So we are talking about how to optimize our code to give better. The coding is important. You know, it's the wiring of our project. Okay. But what is design? Okay, here we are talking about how different components inside the same development environment interact with each other, or inside the same application. We are talking about, okay, this is called the design pattern. What is this design pattern about? It's called proxy pattern. What is this proxy pattern is doing? Okay, the proxy pattern, anyone here knows what is proxy pattern? No one is going to cheat me? Okay. So the proxy pattern is a pattern that isolate external system or isolate another component and make it as it is part of the current application. For example, let's if I want to call Google Maps to get the distance between 2 points in a map, okay? So I can create a proxy, which is a class inside my application. It's a class inside my application. This proxy abstracts how we call Google Map. This class had a method that takes the first point and the second point and returns the distance. It abstracts everything about the API call and how we send the API key and blah, 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 blah. This is called proxy pattern, okay? So this proxy pattern, how I can implement something like that? So it tells us, okay, this is the subject, that's what we are interested in. We are going to create a proxy. This is the application, you can say. It will call our proxy. This proxy abstract a real subject, okay? And this proxy is going to be used by our application. That's how it's going to be done, okay? And you can write this code in whatever language. You can write this code in Java, in C++, in PHP, in Python. It doesn't matter the language. Because any language that is object-oriented programming language will be able to, you are able to create proxy pattern within it, okay? But if it is Haskell or F#, you won't be able to design that way. This is a design for object-oriented programming paradigm.
So I thought that this is actually architecture, so can you please clarify?
Yeah, that's nice. This is a design, not architecture. We have two concepts of design. We have a UI design, and if I'm going to talk about UI design, I have to use the term UI with the word design. But if you say just design, it usually means that the different system components inside the same app have different components. Inside the same app interact with each other. That's what we mean by design. So that's why we have design.
Solution design.
Solution design, it may go to the level of architecture. So it's application design, you can say.
Application design.
At least internal application component design.
What the different way that I can use the Google API, so I can understand the advantage of this
Pattern.
Yes.
Okay.
What is the
other way?
What's the other way?
The other way is calling Google API directly from the main class. Okay. There is a pattern called MVC. Did you hear about MVC? Model View Controller. Okay. This pattern actually simply, let's say that the controller receives a request, right? Do some sort of stuff and create a model pass this model to the UI. The UI render the model, and we see the UI. This is a pattern, okay? So while this controlling doing some stuff.
You can devote all the picture. Depends on the.
Oh yes. Thank you. Okay. So while the controller doing some stuff. Let's say we have the index action. You know the index action? The default action that will open the main page. Okay. So this index action wants to get to the distance between 2 points. Okay. So I'm actually here not targeting to explain what's proxy pattern exactly, but I'm just trying.
I just
yes.
want
them
to understand
yes,
what is the other way without the patterns.
Yeah, that's right. So inside the index action, I can call Google Maps directly. What does it mean to call Google Maps? It means that I'm going to create an API key that equals something, and then create some XML request or REST request. So I create something called request, which is going to be string, right? And this string actually will contain the form how to point to put our points here, like x point x something and point y another thing. You see that? Okay. And then here I'm going to make the call using some sort of network calling tool. So let's call it socket, for example, dot post, and we add our request that we created. Okay? And after that, we write some blah 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 and return our model. So this is a very simplified way of calling a Google API. Okay? So instead of every time doing all of this stuff, I can take all of this stuff in another class called proxy. And I'm going to use Google proxy that way. Google proxy dot get distance x and y. So this is some kind of abstraction, so I don't need to write all this stuff anymore. Creating this class, that's what we call proxy pattern. And that is design. Why it is design? My code now is more clean, easier to update in the future. Let's assume that if I'm calling this logic, immediately this is my code. Remember always, our target is modifiability. Our target is what? Modifiability. Our code should be modifiable. Okay? So if I'm using this code in many places in my code, okay? And in the future, Google changes the way we call its code, its API. That way, I need to update every place that call the Google API. But with proxy pattern, I'm going to update only once, right? Is it clear to everyone?
Yes.
Can I safely go to the next slide?
I was just about to ask you a question, but
Okay, you can ask. Okay.
you said that with using proxy design pattern is the way of object-oriented programming, right? Can we say?
Yes, yes, you can say.
So if you don't use the proxy design pattern, is it an example of functional programming?
In functional programming, I'm going to use a library which
Yeah,
represents
okay.
a class in the object programming world. And so that's design. So what about architecture? So design, when I'm talking about design, I'm talking about design concerns. Okay? What is design concerns? How I'm going to organize my components inside a single app. That's how we can say it. Okay? But actually, there is no clear cut between design and architecture. But this is a pure architecture thing. What is this? This is a pattern called competing consumer pattern. What this pattern is doing? Okay, we had a problem. We have. I was implementing actually many systems. One of them the red crescent, but I will give example with a salary system. This salary system make calculations. It's a SaaS system. You know what does it mean? SaaS software as a service. Okay, so it makes salary calculations, and actually between the day 27th of the month and the day 1 of the next month, in this time, it calculates millions of equations. Okay? Why? Because it's software as a service system. So all companies calculate the salaries of its employees at that time. So millions of equations are calculated. What is happening here? What happens? Something like that. Let's assume that that's the time, okay, and that's the loop. So the loop usually is like that. And suddenly,
Time and what?
this is the time, and this is the loop.
Loop.
Loop. Okay? The loop, I mean number of requests per second.
Okay.
That's what I mean. So the loop is actually most of the time like that. You know, it's like please, someone attended, someone left, this stuff. Okay, it's good. But at a certain hour, and maybe a certain minute, it's just going like that.
Okay.
So usually it goes like that and move and go back. Okay, but what was happening is that when it goes like that, the system collapses. Why collapse? Too many requests in a single unit of time. I can't serve all of that. I'm not ready. I have one instance. I mean, you know cloud? So one instance, I mean one virtual machine, you can say. Okay, one virtual machine serving it. And this virtual machine is ready to serve 1,000 requests per second. Okay, but suddenly I have millions of requests per second, which means collapsing this machine. So this competing consumer pattern is for that. And instead of receiving the request directly to the calculator, I'm using a queue in the middle. And this queue is going to receive these requests and organize it first come, first served. And there is another service, this is the salary calculation services. And these salary calculation services are going to consume that queue over time. So when I have a peak load, I'm going to increase these services that are competing with each other to consume the queue. That's why it's called competing consume. So I'm going to increase the number of services that are going to compete to consume the queue. And when that load goes away, what I'm going to do? I'll just return to the normal load. Okay? And that's very easy actually to implement and to calculate the load, because it's easy to know that this one is busy, so you can add new instance automatically at this one. So you can scale up and scale down dynamically. In what I was saying right now, explaining that pattern. First of all, everyone understand the pattern?
Yeah, can you just have more instances in the competing process?
More examples?
No.
More instances?
You just.
Yes, I can make this up to 1,000 instances, no problem. 10,000, no problem.
So you are reserving new virtual machines, or how?
It's something like that. This is that man is computing that. Okay. So at the normal days, he doesn't have a lot of requests. Okay. But at a certain day, there is a huge number of people are there wants him to serve them. So I will say, oh, okay, we are going to create a queue. And I'll make a queue, I'll make someone here to give them numbers, okay? And I will tell you, all of you are going to serve today. Everybody come here, you won't serve these people, okay? And everybody here are going to serve that those people are out there, okay? And now, one will go here, and that's how it's. And the next day, the load is lower, we will go to your offices.
So
do you mean instead of using the queue, we increase the instances?
No.
To solve the problem?
I mean, this, are you capable of reserving machines as you like? Is that something?
Yes, because in Amazon and Azure Cloud system, you are using Azure Cloud. You can use Azure, Amazon Web Service, whatever. All of them will provide you.
So you can just
yes,
reserve as many as you want, and
yes, and release
the
them.
next minute
And
you don't need any of them. So
I'm just getting them. Yes, I'm just getting rid of them. I'm free to do that because I'm cloud-based and service-oriented. Okay. And what I said.
I want to add something here, because this is normal misunderstanding. that sometimes with the cloud architecture, if you have cloud architecture or you have money, let's say you have money and you can make, like Hamza said, a lot of instances and I can scale up. If you don't have the right architecture, you will not do this. Do this in the correct way. You need a well-designed architecture to be able to be scaled over the, let's say, the hardware.
Yes.
Because the cloud is just virtual hardware.
Yes, just
So-
virtual hardware.
So you cannot scale with just scaling the instances alone. You
Alone, yes, you have to have a
design
good
the
design, actually. Because this architecture requires this to be stateless and require this stuff to be, we can say, discoverable. There's a lot of stuff here. You know, I'm just saying simplified version of that. Okay, but anyway, that's right. It's important thing. Thank you for that question, actually. But anyway, while I'm describing that, did I say C# or how the component of the application will interact? How many applications here? Many applications are interacting with each other, right? This one can be a Java app. This one can be a PHP app. This one can be a C# app. This one X app, I don't know, okay? And this queue can be ActiveMQ. It can be RabbitMQ. It can be Azure queue. It can be the Amazon queue. Whatever queue I can use, okay? And these services are going to be with the same language, usually, okay? But it can even be different language. But I'm not crazy to implement that application and implement
The same
payload,
application
the same application. Yes, I want to make it, and the same function.
The same function
Because
and the same
all
server
of these
and
are
the-
calculating, yes, they are calculating the salary. So it's like calculating the salary in PHP and calculating a salary in C#. So I'm not, for sure, I'm not going to do that. Okay, but anyway, these functions can be that way. And to give you an example of exception of having multiple services doing the same thing with two different languages is a problem that we were facing right now, and we solved it actually. But we were trying what is the best language that can receive the highest number of requests or serve with lowest number of time for calculation. So we tried with Go and with Node.js, and we did that actually. They can work side by side. How they can work side by side? Because they are consuming the same. Okay, that's what you mean. You mean 30 minutes. Okay, that's nice. I'm slow? Or is that way the speed?
You're asking questions.
Okay.
No. You said I'm being slow, but I said yeah, asking questions because of that.
Okay.
Yeah,
You are not slow, but they ask us.
Yeah. Okay, so let's start with code. Now we understand the difference. When we say design, you have that vision of what is design in your mind, and when you say code, you understand what we are going to talk about right now, right? And when you say architecture, you have an overview what's architecture. Okay. Writing code, is it important?
Yes.
Sure, it's important. And this is a good example of how much important it is. Okay, so this is a clean code and this is a messy code. That's the same exact example. Okay, so messy code actually gets you into a loop of having a messy code, so you have lower team productivity because team is now more worried about teach each other than writing code. Okay, and after that, this will cause more stress. We cannot do it. We cannot deliver. And this more stress will add, the company will decide to add new members, which means it will miss the design intent more. What is the design intent? The design intent, I'm designing this application to do something. But because the code is messy, I'm over time corrupting this design. So the more corruption to the design, the more messy code I will have, the more bugs that will be hidden, the more problems I will suffer over the time.
And adding more members are not the solution.
Are not the solution.
You are
And I have a very fresh example right now. Okay, I just joined a consultation for a company from about 3 months from now. They were 6 months trying to deliver. 6 months trying to deliver, and they are suffering because every time they add a new feature, it takes a long time for this feature to add, and it causes a lot of bugs. So they are not adding any more features.
I have the exact same situation happened with me. Yeah, exact same time. Maybe same company.
The same company. So we are consulting the same company. You remember when I called you and asking you what is better for developers to understand? It's a block pattern or provider pattern, and you advised me with provider pattern.
Yeah.
Thanks for him. So why I did this exercise? Because I need a pattern that developers can use and understand fast and organize their code fast, and now they can be productive. So what I did actually, usually the companies, it's like that. We need to deliver. It's 6 months. We have to deliver after 1 month. Mustafa, come to solve the problem of 6 months in that month. Okay.
One day.
And 1 day, yeah, it's something like that. I'm saying the last thing that I asked him, when you want to deliver, in the long term or the short term? He said mid-term. I said, oh, nice, 3 months. So he said, no, 1 month. I told him, 1 month is the mid-term. So anyhow, so what I did actually is just reorganizing it. I will show you a sample of the code. How to, but and that actually will give you like a clear anyhow, you trust me. Okay. So actually, that makes good. I'm sorry, I couldn't find the file. I just got a sample, and I cannot open the code in front of you from what company, so I cannot go to the folder. Maybe in the next section I will read the code again. Okay, because it's actually I need to get it from Git. You know. Git. Okay. Okay. Anyhow, the miss code caused the program not to deliver it. Okay.
Did you deliver on 1 month or in 3 months?
Actually, what we do in that in such problem, I promise to make a change during that month. Okay, it's like you will see a change, you will see something better. And what I'm doing actually, I'm doing like a gradual fast delivery. I took 2 weeks with 0 deliveries. These 2 weeks is just making like the smallest possible code reorganization or code cleaning. After these 2 weeks, we start to try to deliver in the next 2 weeks. And we succeeded to deliver something at the end of the month.
Because of your question, I want one more. As a consultant, we are not doing anything without our hands. We are not going engaged and write something. We are engaged at the code level. We can engage at the code level to observe and find the problems. But the team themselves, yes, they have to follow the process and follow the clean code and follow the architecture, and we under our consultation to do the right things. Otherwise, we just solve the problem and ourselves, we cannot do this. It's one guy with 6 months failing team.
Yes, the team, okay, the team was working with me, but I delivered like a small, it's like a half day to tell them how to organize the code. We have the pull request. We have some stuff that help us. We need to talk about pull requests at least.
Of course, inshallah. Before I, inshallah, we'll talk about the process on Git or GitLab. Sorry, sorry.
Yes, it's good. Okay. Because actually
It's not Microsoft.
it's very
It's good news.
Okay. So the productivity with messy code, it's high at the beginning and lower over time. And I promise you it will be zero at a certain time. Okay, and that's what happened already in that company. Okay. By the way,
I have one
for your question, I delivered after 3 months,
Okay.
but using agile methodology, they were happy. It wasn't.
How the team starting generating messy code?
How the team started to generate messy code. Okay,
This is for you. I'm asking about
because they weren't washing their hands before making the surgery. So what's happening actually that we don't have time. Okay, so we don't have time
to follow the design.
to follow the design.
Yes,
That's right.
yes.
So we want just right. We want to deliver. Okay, how the UI is going to be? It's like that. Add the thing to me. Okay, I want to see that part. So the add functions to the same file. So we have like a big Dart file that contains the business code and the communication code,
Everything.
the messaging code, everything, the arrow handling code. So it's like one big Dart file. Okay, and unfortunately, even with a bad names, okay, they were using, for example, index. What's index? Index of what? And this index something crucial. It's used in many places.
Yes.
So it was at the beginning like a decoding something, not dealing with a code. So discussion here. How many times you try to tell your manager that we need to refactor? Refactor means a better code, to make a better code. Stop doing that code and make a better code.
Well, the only reason would be because he will yell at you.
You what? Sorry?
He will yell saying.
Oh yeah. He won't. Usually the answer is we don't have time. Even when they get me to them, they said we don't have time. You know. So
Yes.
why you are getting me?
You know, answer.
They
We
were-
don't have time, but we have
Yes,
plan.
I had the first week a fight with the management, and I used to that. So I was usually when I'm consultation service, I had the first 2 weeks or 3 weeks in a fight with the management and with the employees. The employees are happy,
Yes.
but I mean like semi-fight with the employees because I'm stressing them to do the code the way they are not comfortable to do it.
And isolate them from the match.
And I'm protecting them actually.
Was the manager a software engineer?
Yes.
So why did he start doing fighting if he knows that the problem is from?
Because he's software engineers that are not coding anymore. He faces a client who is yelling on him. Actually, software when you go into the software development field, you will feel like you are in a World War II. Okay, so at a certain time, we need to deliver. We have these features. The client wants that, and we always in a fight. The man, there is, you can say, people on the line. Those people on the line are seniors or software architects or Scrum Master who are trying to protect the developers and make them do their work, and at the same time get the yelling from them. Because the developer usually we are trying to provide a good environment for him to develop, because his brain is the pressure thing we want to protect. And also we force him, we stress him at the same time, but like you can say soft stress. You need to make a soft impact, a soft stress on the developer, and you take the cautious. Usually, I don't know the translation, but in Arabic we say Sa'adin. Sa'adin. Like the, Sa'adin of cars. Sa'adin. You know the car, the springs of the, yes, you are the spring. You take, they push and give it slowly at the other side. But they have to feel the push, but slowly. So the question is, can the doctor, are you okay for a doctor to make a surgery without washing his hands? Sure, we are not okay. Confusion. Okay, so we talked already about that. Yes, that confusion. I think we would slow down and stuff. I'll give enough examples. So I like this wisdom quadrant. What is wisdom? This quadrant you can make it like for your whole life, not only for design decisions or clean code decisions or whatever. Okay, I'm using it for architecture, for clean code, for my life. So what is this about? Let's think about that we have this quadrant, and here let's make it. I like to make it like. Okay, so here this is a reckless action. You know reckless? Reckless, not okay. It's just like that. Okay, not interesting. And prudent, it's wisdom action. Okay, I'm thinking before taking the decision. Okay, and here deliberate with your will. You can be reckless with your will, and you can be reckless with wisdom. Yes. Yes. Yes, the deliberate. Oh, sorry, deliberate. I mean, this deliberate is okay. Deliberate, yes. It can be deliberate reckless, yes, because this is the weird box, and this is another weird box. I'm deliberate with reckless because I'm deciding that I'm going to drive the car with very high speed for no reason. For no reason, for fun. I'm happy with that. I'm making an accident. Yahoo! I didn't die.
So for
Still
example,
alive.
where does that go?
I'm still alive, yes.
What box does that go to?
Hmm?
The driving car for no reason.
It is reckless, deliberately reckless. I'm reckless and I mean it. Yay, I'm happy.
I think Zara is meant by definition in the software.
Ah, okay, the software, I'm going to touch that in software. I'm just trying to make you imagine these boxes in your life. And for that one, when you are wisdom, but doing like a reckless thing, inadvertent means without wanting to do that. Okay? Unconsciously, something like that. When you have someone in your car that's sick and you need to deliver him fast for emergency, you are driving fast and you are not thinking about anything. Okay, so it's wisdom, right or not? If you go that slow, everyone will, are you crazy? What you are doing? So let's go in that software. The first box, I am with reckless. It's what's learning, what's software design, what's clean code. Okay, I'm just coding. That's it. I'm throwing my hand on the computer to code. That's it. But reckless, and you mean it, like we don't have time for design. We don't have time for design, which means after 6 months you won't deliver. The happiness of the first 2 months will go away. Here, we must ship now and deal with the consequences later. Okay? I am intentionally, with wisdom, may leave some design decision behind. But I put these design decisions that I left behind in a backlog, which we call technical backlog, to solve it later. You aware of that? So I am deliberately, with wisdom, decided to not make this design that I believe it's correct. Okay? But I'm taking care about a lot of other designs. For example, like proxy. I don't have to make a proxy in the right way. I'm just, for now, I have a certain feature that I need to deliver. So it's like I'm containing the bad code in a certain place until I solve it later. Okay? But I may sometimes do something wrong because I don't know. Okay? So this is the square. So you should live in which part? Do you think you should live here or live here? So take care, always be on that side. Okay? Okay. So writing code is not an easy task. It is some things to say this man is the father of C++. Talking about the clean code, Grady Couch, the father of object-oriented or software engineering. You can say like biblical man of software engineering. Stoking say clean code never obscure the design intent. So if you are understanding what is the intent from that design, you should write a clean code that helps keeping that design intact all the time. Don't corrupt the design. Okay? Don't ever corrupt the design. Okay, so the godfather of Eclipse strategy, you know Eclipse? It's the most famous tool for software development environment. Okay, so it's a clean code can be read and enhanced by developers other than its original author. And this is very important actually. Developers other than its original author. Okay, so to know if your code is clean or not, some other developer should say, oh, what a nice code. Yeah. Not say the other thing. Okay, it has unit and acceptance tests. Okay, why? Because it should be modifiable. And yet an acceptance test will force this code to be clean. It has meaningful names and provides way to rather than many ways of doing one thing. Reusability. Okay, and it has minimal dependencies which are explicitly defined and provide a clear and minimal API. This is abstraction. All of these things are design decisions, by the way. All of this stuff.
So for a clean code, let's say that we have a software developer who writes a very clean code, and he has a fellow developer that doesn't write a clean code.
Yes.
So how to solve this thing? Like for example, I'm writing a clean code. He's
By pull requests.
Excuse me.
Pull requests. Okay.
Code review. Yeah.
Okay. What's a pull request? Actually, you are not just writing your code and throw it in the code base. We have something called code. Okay. And this code base is in a place that's shared between developers, but they are not directly shared. For someone like Abdurrahman. For Abdurrahman, for example, okay, he wants to write his task. He will create an instance of the clean code we have for himself. And this instance, we call it a branch. And this branch, he will develop on that branch. And we will submit his code, but it will not affect the main code. It's in a branch. After he finishes his work, he will ask someone to review his code that's going to merge on the code base. This man in the middle will look at that code and will tell him, oh, what is this A? What is this B? What is that variable name? You are not following the design here. Why I see the context inside the view model? Okay, because he knows that this will be the future. So
the testing in the
so this peer review,
the testing developer, he's the one to make sure that
not testing. It's
one
another developer.
of the acceptance tests.
Code review.
This is one of the acceptance
Was
tests.
it acceptance? Yeah.
One of the acceptance tests, yes. Number 2, I think. is
Yes, and acceptance
write
tests.
this code before you merge to the branch. You make your peer review or senior review.
Yeah,
Plan your mind with this.
that's right. And so you want to say something?
I just tell code review. That's another name.
Yeah, yeah,
Someone
code
reviews
review.
other one's code.
So someone else will go into review. Okay. And all of this stuff actually is design stuff, so I'm going to talk about it later. But this means that to make a clean code, you need to have a well design, beside nice names, beside small functions, besides all of that means clean code. Time? 5 minutes. Do you have 5 minutes? Okay. So clean code is about written by someone who cares, but this one actually I like very much. Usually leave the campground cleaner than you found it. So when you go into a code, you don't just write your code inside this code and say some words. Okay? No, make it cleaner, make it better. You know, there is hadith saying إماطة الأذى عن الطريق صدقة. Removing obstacles from the road is a charity. Okay? So this hadith actually makes all routes clean, because everyone go to the route will think how to make it better when I'm in that route. Okay? So it's the same. If every developer, when he touches a code, think how to make it better while leaving it, sure that code will be always clean and with minimal effort.
So am I allowed to modify someone's code?
Sure, you are doing that all the time actually.
To what extent?
But for example,
Accommodate
To what extent am I allowed to?
it depends actually. Because if the code is well designed, well organized, you won't have to modify it you can say, have extreme modification for it. Because it's like creating another function that will be called by his code or something like that, okay? But if it is a miss code, for sure you will modify it. So what you are going to do, change the word index to channel index. Change the other word index 1 to device index. These two words actually made me suffer for 1 hour or more. If it is from the beginning channel index or device index, I would be happy a lot.
We're allowed to change like a whole.
Yes, so I need to read the code, change stuff.
But what if he, for some reason, told me afterwards that he didn't like my changes?
You won't, because he's a senior who review your both codes. You are not enforcing your code, you are doing something better. Usually, when you do something better, everyone is happy. You know? But if he discussing that with you, you need to listen, because maybe you did something in a wrong way. Maybe he has a certain loop for some reasons that you don't know. And actually, sometimes we are afraid to update the code. I will take this 5 minutes, this 1 minute, like that story. We had a story where we have a code, and we found like a database code inside a for loop. So I asked the whole team, no one knows what this code is about, and we need to deliver. So actually, we don't know why he is calling that place. So everyone was afraid. So they got me, and they said, we don't know who added this line of code, and no one here added that line.
Yeah.
Actually, sometimes it's not traceable because someone just cut the whole method, put it in another class, so that all the trace is stuff to make. So, okay, so what was our decision? Is just to leave it and like to do over it, because sometimes you just remove a line of code and you don't know what it does because it's not clean, it's not descriptive, it doesn't have a comment over it. So you remove it and you find suddenly the system is freezing for no reason. Okay. Anyhow, we found that this line has no meaning.
You have to keep it with a line comment like this.
Yes, with a comment, a to-do comment, to be in your technical backlog. Let's meet after 10 minutes from now to continue on our next session. Thank you.
Thank you.